phone cameras are a wonderful invention. The reason they are used more than normal cameras is because of the convenience. One just needs to pull their phone out of their pocket and click as many photos as they need. It is able to artificially simulate photos taken by real cameras using less than half the resources. Cameras can take beautiful pictures like this. But they can also take terrible pictures like this. The second picture is taken in the dark. The second picture is bad because phone cameras don't work well in the dark. To understand this, we have to get into something called exposure. Exposure is mainly dependent on three things: aperture, shutter speed and ISO. As shutter speed is mainly constant, we will ignore that. In optics, an aperture is a hole or an opening through which light travels. The closest thing that we can relate it to is the irises of our eyes. They contract when it is too bright and they expand when it is too dark. With professional cameras we can control the contractions and expansions of the irises of the camera. A high aperture would be the expanded irises and a low aperture would be contracted irises. Aperture and exposure are directly proportional because the more light you let in, the brighter the image would be. Now the problem with phone cameras is that you can't change their aperture. The fixed aperture leaves a tiny hole for light to be exposed to the sensor. During the darkness, as there is a lack of light, we won't be able to see anything. But this is where ISO comes in. It is the sensitivity of the sensor to light. This is also directly proportional to exposure. But as you increase ISO, the amount of noise in your image increases. That is the graininess you see in the second picture. The phone uses ISO to compensate for the small aperture in the image. Therefore it looks bad. Now, let's discuss how a phone camera is related to a mirror. As light rays pass from mirror to glass, they bend or refract. A concave lens makes them refract outwards, or diverge. A convex lens makes them refract inwards, or converge, to a focal point where they form a clear image, as in the camera. But, phone cameras have multiple convex lenses which allow us to take pictures with optical zoom without reducing the quality of the picture drastically. Why do phones have multiple cameras? For this, we need to do an experiment.
The depth perception that your stereoscopic vision provides is one of the most important tools in your visual toolbox. To illustrate just how useful it is, try this simple experiment. Take 2 coins, preferably of the same size, and pinch one in each hand. Raise your arms at your sides and quickly touch the edges of the 2 coins together in front of you. Not too hard, right? Now reset your arms and try it again with one eye closed. Without slightly different perspectives from both eyes creating a helpful sense of depth, the task becomes much harder. The way our eyes are positioned and the keen depth perception that comes with them gave humans evolutionary advantages that have helped us survive and thrive. Thank your depth perception the next time you're able to take the money and run.
This same logic applies for phones with multiple cameras. Multiple cameras mean multiple angles, which helps the camera figure out depth so that it can create focus. Also, more lenses means more light, which means more data to process and make a better picture. You must have seen ads where people say that a phone camera has 16 megapixels or higher. CMOS sensors, complementary metal oxide semiconductor sensors, are semiconductor image sensors that convert light into electrical signals. The higher the details of light that can be collected, the higher is the amount of pixels. A high megapixel camera is able to capture more data from the light. Although higher megapixels do increase the detail captured by the phone, the sensor of a phone is too small. There is very little area for light to be projected. Hence, the brightness of the image suffers. Like aperture, ISO is used to increase exposure in a low lighting setting. However, they can create pictures with great detail even if enough lighting is provided.
The part of the image highlighted in the diagram below is the size of the pixel highlighted above, which means that 1 pixel in the 12 megapixel camera is the size of 9 pixels in the 108 megapixel camera. Now, the amount of light energy in an area is more than the light energy on a smaller area. My point being that the amount of light received by a pixel of 12 megapixel camera is more than the light energy received by a pixel in a 108 megapixel camera. So, a 12 megapixel camera will receive light better compared to a 108 megapixel camera.
Limitations. 1. Low quality optics. Smartphones are made to be slim and small enough to be put in your pocket and be carried around. As phones are so compact, it isn't possible to build them with the same sort of lenses you would find on the DSLR. The net results. A small built-in lens is vastly inferior to a professional camera lens. Good quality and appropriately sized lenses are necessary to get good pictures, which isn't possible due to the phone's compact design. 2. Poor light sensitivity. Good lighting is necessary for one to click good pictures. If the lighting isn't proper, the photos that are clicked will be grainy or distorted. People often tend to judge a smartphone's photo capability by the number of megapixels it has, but that's only a fraction of the story. Good light sensors can enable your camera to pick up enough light to ensure you can take a good picture without flash. 3. Digital zoom. Not all cameras have optical zoom, that is, zooming into an object without drastic deterioration of the photo quality, but it is only limited to a certain extent. Hence, most phones avail digital zoom, which allows one to magnify the image much more. The issue with digital zoom is that the object becomes blurrier and highly pixelated, as the processor tries to crop the image to zoom in closer. This deteriorates the image quality, making it difficult to recognize the objects in the picture. 4. Non-ergonomic shape. Phones are mostly rectangular in shape, and their cameras are placed either to the top left or top right corners. A lot of times when taking photos, people grip their phone between the tips of their fingers. Sometimes a person's fingers may interfere with the lens's view, causing their fingers to be seen in photos or videos. Also, this is not the most secure way to hold a phone. One slip and your phone could fall to the ground and suffer some serious damage. Cameras have a bright future ahead and will be playing a major role in future smartphones. Currently, there are many different ideas out there regarding phone cameras. A few of them are: 1. Periscopic cameras. These cameras work on the basic principle of periscopes, which are often used in ships and submarines. In periscopic cameras, a mirror is placed slanting at an angle such that when the light enters through the camera lens, it gets reflected at an angle of 45 degrees and reaches the sensor, which then processes the data to give us an image. Currently, they are able to provide optical zoom of up to 5 times, which means there is no decrease in quality of image by zooming. Eventually, this technology can be further improved to provide zooms up to 10 times or more. Periscopic lenses could eventually also provide optical stabilization. 2. Ultra-compact cameras. The concept of ultra-compact cameras has been around for quite a while now, but we do not see it being used regularly. What is an ultra-compact camera? It is a camera which can fit in your pocket without any issue. They have highly developed sensors which do not compromise on quality unlike current phone sensors. 3. Artificial intelligence. AI or artificial intelligence is soon going to take over the world of cameras. AI cameras think and learn about the settings and the image processing. Smartphones equipped with powerful AI processors are able to quickly recognize the scenes in which the photos are taken, as well as automatically differentiate between foreground and background objects. 4. High-resolution sensors. The sensors present in the smartphone play a very crucial role in the processing of images clicked by the camera. The better or stronger the sensor's resolution is, the better the processed image will be. The newly introduced ISOCELL HP1 by Samsung is the world's first sensor with a 200 megapixel resolution. This sensor will allow a person to click images which are clearer and better than other phones.
So, as we said before, exposure is controlled by 3 elements: aperture, ISO, and shutter speed. We covered aperture and ISO, but we have yet to cover shutter speed. Now, we didn't cover shutter speed because shutter speed does not really change automatically by the camera in normal mode. But our phones have a pro mode or a movie mode in which we can change it. So here I have a phone camera, and so on the right you see these 5 options. Now they are EV, AF, WB, S and ISO. EV is the overall exposure. So if I want, I can increase it or I can decrease it. Now this changes the ISO. So you look at the ISO. You can see. Now if needed, it can also change the shutter speed simultaneously. Now we have autofocus. So here I have a keyboard, and you see the reel on the right moving. It's because due to the dual camera setup, it's able to detect the depth. So right now I want to get the furthest point into focus. So I'll turn the reel up. Now you see that the furthest point is in focus and the rest of it isn't. The nearer part you can't see. Now you can bring the nearer part in focus, and now that is not in focus. So good changes anyhow. Next is white balance. White balance is the temperature of the image essentially. So I'm using this white wall as a reference. I want to bring the temperature up, so I'll bring it to 6000 Kelvin. You see the image is warmer, and now I bring it down to 2800. The image is blue. So next up is ISO. Now I'll use this black book as reference. So you see that the ISO is higher compared to here, because to be able to save the information of the black book, it has to increase the sensitivity of the sensors to it. So now if I increase, you see the noise in the image that is caused due to the high ISO. Now if I lower it completely, you see that the noise is no longer seen, but you can barely see the image. Now it's normal. So next we look at shutter speed. Now shutter speed controls the speed of the shutter. So the shutter is basically like a curtain that covers the sensor, and shutter speed is a fraction of which in seconds the shutter opens and closes. So now the faster the shutter opens and closes, the more images it can save. And video is a series of images that are played in quick succession. We are not able to individually pick out the images because of something called persistence of vision. So I will demonstrate shutter speed. So if I want to say lower shutter speed, you see the image is quickly reacting to my movement. Exposure is less, whereas when I take it to high, the image exposure is higher, but any movement I do is making me look like a ghost. Now this effect is used to convey something in movies, but it's not really useful in normal circumstances. So yeah, that's pretty much it.